panel, the physical sciences covers a vast territory: geology, astronomy, physics, and chemistry. The panel consists of Professor Richard Zayer, Professor of Chemistry at Stanford, Professor Govardhan Mehta, Professor of Chemistry, University of Hyderabad, and Professor Ramaswamy, Professor of Physics and currently Director of TIFR Center for Interdisciplinary Studies in Hyderabad, Professor Ramesh Narayan, Professor of Natural Sciences at Harvard. My own specialty is experimental astronomy. I'm happy to announce that our group has chosen Dr. Shrivari Chandrasekhar of CSIR Indian Institute of Chemical Technology, Hyderabad, as our winner for 2014. So let me read the formal citation. For his diverse and notable contributions in synthetic organic chemistry, with special focus on synthesis of complex molecules from natural sources, he has devised innovative practical approaches to pharmaceuticals of current interest to industry. It's a double pleasure when a scientist does something that advances science and actually returns back immediate value to society. For most of us who are scientists, the value is far more in the future, and sometimes we even wonder when it'll appear. So chemists are lucky that way. Now let me explain both the value of his work and why we, which is a physical sciences panel, as opposed to an engineering panel, chose him. The value is clear for society: cost-effective techniques for synthesis of drugs. Among these, for example, is bedaquiline, the first drug approved by Food and Drug Administration, FDA, in over 40 years for the treatment of multi-drug resistant TB. He, along with his team, has developed an approach for misoprostol. It's a hormone similar to biologically important synthetic prostaglandin. Now you can see why I had to write my notes on my computer, because these are words I normally don't use at all. This particular chemical drug is used to prevent gastric ulcer, induce labor, and/or safely terminate unwanted pregnancies. Our panel was struck by not just the application, we're not demeaning that, but we were struck by that the general approach he and group, an extensive group of students and postdocs have developed. So in science, deeper understanding of general approaches are far, far more valuable than specific achievements. So let me explain what's the basic idea of organic synthetic chemistry. So the primary goal of organic synthetic chemistry is to come up with methods to synthesize chemicals of desirable structure at low cost and without causing industrial pollution. Organic chemicals are composed of three elements: carbon, hydrogen, and oxygen. So a chemist has to learn how to take ordinary organics, example, benzene, alcohol, glucose, and cut appropriate segments and stitch them back in a specific order so as to yield the desired organic chemical. In order to bring these various constituents, you need a solvent. For example, when you want to cook rice, you add water, you heat it up, and the water acts as solvent, and most of it evaporates. In the end, you have the cooked rice, and your solvent is not harmful. If you did the same thing with benzene, it won't be very good. It is a good solvent in many other respects, for example. So solvent should not be hazardous. Next, in order to speed up the reactions, you could say, well, I'll just heat up something. That's how you cook rice. But that's not good enough to make these various functional alterations. The most effective way to increase the chemical rates is through use of catalysts. The most effective catalysts are palladium, osmium, and ruthenium. Unfortunately, these metals are also very poisonous. And even a trace presence, so if you use a catalyst, any of these, and by some chance a small amount goes in your drug, then remember it's a catalyst. It goes inside your body and start catalyzing things again, not to your well-being at all. So in order, you need the catalyst to actually make these in a finite amount of time, and yet when you make them, you can't have them because they will continue catalyzing, which is not the purpose. So Dr. Chandrasekhar's contribution has been the promotion of PEG, polyethylene glycol, as an alternative solvent with the additional benefit that The expensive and poisonous catalysts, such as palladium, osmium, ruthenium, are retained by PEG following the extraction of the desired organic chemical. Another complication of making drugs is to ensure the drug has right chirality. Now, this is something, again, you may not be normally thinking about. Carbon, you see, is got 4 bonds. So it's a tetrahedral. And so when you make a chain of organics, there are 2 ways in which you can arrange the hydrogen and the OH, let's say from the top. One is right-handed, the other is left-handed. So you have 2 kinds of glucose that have exactly the same chemical composition. However, one of them is right-handed, as shown by propagation of light, the other is left-handed. One type of glucose, the one we normally eat, is sweet and has a certain handedness. Most of organics that nature produces have the same sense of handedness. The other type of glucose, exactly the same thing, but opposite handedness, doesn't taste anything, which is good. At least it doesn't kill you, because sometimes the opposite can hurt you. For example, the drug thalidomide, the difficulty with this drug was that the chirality was not recognized in the 60s, and therefore when you took the drug without mixed chirality, you had problems, especially with pregnant women, and the children were born with thalidomide-induced problems. Now, of course, this is known, and drugs have to obey a very strict level of purity and chirality. So for this, Dr. Chandrasekhar came up with this great idea of starting off with natural products. Nature, for some reason, produces very high level of chirality of the right sort for us. And he starts off with that as the base and uses this, then the PEGs, and then the extraction and the solvent. So you can see that he's basically hit upon a generalized approach to making drugs. So we, in fact, our panel is suspect. Not only will be hearing about his achievements through newspaper every 6 months on this drug and that drug, because he's got a little formula going that works very well, but likely many of you will be beneficiaries of his inventions in the very near future. So congratulations again.
Please welcome on stage the winner of the Infosys Prize in Physical Sciences, Professor Srivari Chandrasekhar. May I request Mr. Chris Gopalakrishnan, Anchor Trustee, to join us on the stage. Thank you. May I invite the professor to say a few words, please.
I'm really very privileged and proud to be standing in front of a galaxy of people in the town of Calcutta. So on the stage and off the stage, I could see Professor Mashelkar who has been a great mentor to CSIR for a long time. And of course, my beloved son, Bhargava, a wildlife photographer, who taught me a passion. I never had a passion except killing my time in the lab, but he taught me how to spend time in the forest. My wife, Bharti, who has been with me for the last 30 years now, 27 years. And few of my students who flew into the audience actually from Hyderabad. So in front of them, receiving this honor from Professor Amartya Sen has been a great honor. Thank you, sir, and thank you, Infosys, for this great honor. And actually, whatever I would like to share with all of you, I'm delighted that so Shrinivas Kulkarni has shared with you. But very quickly, what we try to do and why we do. I think the objective of my research group has been to provide affordable health care through innovative research and provide drugs using chemicals which are easily accessible. And bedaquiline is one such great example. And tuberculosis is one of the major disorders, which is an infectious disease. If you look at the World War I, when there was no science, hardly 6 million people died during the whole World War I. Went into World War II, we had better ammunitions, and we could kill 60 million people. But imagine tuberculosis is a small bullet-shaped bacteria, and which is living in all of us. And if this guy becomes like virulent, I think over 1/3 population will disappear. I think this is the objective of all the scientists, researchers, that hopefully we make some drugs which save us and keep this planet for a longer period. And many people who suffer from cancer and CNS disorders, hopefully our research work will inspire youngsters to come into science, take up science as a challenge, and make this planet disease-free. Thank you all.